We got chapter 13.1. We got sets and counting. Again, this is all of chapter 13, which is going to eventually get into probability. Okay, so we need to know our total amount that we're dividing by, our total set. And that's kind of the start of this, is understanding sets and how to count those. Okay, so today we're going to look at 4 goals. Goal number 1 is intersections and unions of sets. Goal number 2, we're going to talk about the complement, right? Goal number 3, we're going to talk about what we call subsets, which are littler sets of the original set. I'll explain that. And last but not least, we're going to talk about count the number of elements in a set, which if you can do a Venn diagram, it's not too bad. So let's take a look. A set is a well-defined collection of distinct objects. So for example, we're going to use little brackets, okay? And for example, you might see like set A is 1, 3, 5, and 8. Set B is 3, 5, 7. Set C is 2, 4, 6, 8. Who do we appreciate? These objects inside are elements. So 1, 3, 5, and 8 are the elements in set A, okay? And we would say that set A has 4 elements, okay? Set B has 3, 5, 7. It has 3 elements. All right, so the objects of a set are called the elements. If a set has no elements, it's called the empty set, okay? Also known as the null set, and we denote that with a little circle with a slash through it, so we've seen that before. Yep, come on. All right, so let's go ahead and take a look. We got a few vocab words we got to talk about. First thing is the intersection. Think of a Venn diagram. When we're talking about the intersection, we denote that with a little upside down U. So we say the intersection of A and B, okay? Now, some people think that's an upside down U. For me, I think that looks like an N for intersection. And the intersection of A and B is right in the middle, right there. All right. Well, his opposite, buddy, here, the union, we use a little U for union. The union of A and B, I think of union, I think of like a marriage. What's yours is mine now, okay? And that's kind of true in the real life. When you get married, right? What's yours is mine. If you marry a gal or a guy that has $1 million, now you have $1 million, right? And also the bad part is if you marry somebody that has $100,000 of school debt and you marry that person, guess what? Now you have $100,000 of school debt. Okay, so union is what's yours and mine put together. All right, so what's A or B would be everything considered here. So what's in A, what's in B, or what's in the intersection of A and B? That's the union. That's like a marriage. Put them together. Now it says if A and B have no elements in common, that is the intersection of A and B is the empty set, the null set, then we call that disjoint. And that's unfortunate. Like in the real world, sometimes a marriage looks like this and then they grow apart, right? And then, oh, they're no longer together. They're disjoint, all right? Like my parents are disjointed because they don't have anything in common anymore. Tear. Promise I wasn't going to cry. No, I'm just kidding. Well, I'm not kidding. My parents are divorced, but I'm not going to cry about it. All right. I'm 40. I'm not going to cry. All right, so we take a look at some examples here, guys. As we take a look, I got example 1. I've got the union of A and B. So I got A is, again, 1, 3, 5, and 8. And I like to write these out, especially for notes. So I'll go ahead and do that. The union of B is 3, 5, and 7. So union, again, means put them together. And when you put them together, you don't write them twice. Okay, so union is a marriage. So put them together. I got 1. I got 3 and 3 only write at one time. I usually write these in numeric order. So 5, and then 7, and then 8. And then that's my set. So I make fancy brackets. Try to do your best with the brackets, guys. So my final answer there is 1, 3, 5, 7, and 8. My math club, you'll have to use the commas probably in between the numbers, right? Unless it's a multiple choice type question. But I think, again, I'm giving you a worksheet for homework tonight, so don't have to worry about that. Example 2, I got the intersection of A and B. So if I take a look, I got A again is 1, 3, 5, and 8. And I'm doing the intersection with B, which is 3, 5, 7. Okay, so what I'm looking for is what do they have in common? And what do you guys see that they have in common? 3 and 5. So that's my final answer is they have 3 and 5 in common. So then to make this harder, because that's pretty easy, right? To make this harder, then they start putting in multiple unions and intersections. Okay? Well, they'll tell you which one to do first based on, please excuse my dear Aunt Sally. So please excuse my dear Aunt Sally. We do this guy first. We have already done the union of A and B, right? We did that over here. Okay, so the union of A and B we did, and we got 1, 3, 5, 7, and 8. Okay, and now I'm doing the intersection of C. C is 2, 4, 6, and 8. So this is again the union of A and B. This is C. Now do the intersection. What do you guys see? What do they got in common? They just have 8 in common, right? So only 8. I always get, Mr. Gotsch, you make such pretty brackets. Well, thank you for saying that. This is how I do it. I start up on this one, I go to the middle, and then I go to the middle and go down. And I do the same thing. I start up here, make a little, like a 2. But if I do that down here, then it all gets all messed up. So I start here and make like an S on that one. So basically I'm making an S and a 2, and then an S. All right, all right. So when I take a look at the next one, number 4, please excuse my dear Aunt Sally, do my parentheses first. So I'm going to do this one first. I'm going to do the intersection of A and B. We've already done that, right? In example 2, intersection of A and B we know is 3 and 5. And then I'm going to do the union with C. So again, C is 2, 4, 6, 8. Union, again, is just put them together. It's a marriage. So now it's one big happy family. All right? So you take these kids and these kids, you put them all together, and you write it numerically. Right? So the first number I see is what? 2. And then this one has a 3. And that one has a 4. That one has a 5, 6, and 8. How's that? Look at that happy little family. Y'all have any questions? No questions. Nada, nothing. Easy peasy. Want to do number 5? Or are we good? Does 5 look scary, or do we need to do it? Skip it? Skippy skip? All right, we'll skip number 5 for today. Let's move on to the back side then. Number 5 is pretty easy, so we can skip it. All right, so now we got some other vocab things we got to talk about. All right, so when we take a look, it says designate the universal set is denoted with the little capital U. Okay. And it's a set consisting of all the elements that we wish to consider. Okay. So that means everything in our set. So you might like give out a survey, and you got to count how many surveys that you gave out, and recorded answers from. Now, some of those surveys might have, answers for question 1 and question 2. Maybe we'll talk more about this later. We'll have a survey of 100 college students later. So you gave out 100 surveys, that's your universal set. And something like this, when we're dealing with numbers, you'll see set A is like 1, 3, 5, 7, and 9. Well, my universal set, instead of just saying it could be anything, we limit it down to, in this case, 1 through 9. So all of those numbers, 1, 2, 3, 4, 5, 6, 7, 8, and 9 is my universal set. Okay? Well, we're going to need that, so when we talk about the complement, so I'm going over to this box, the complement is the set denoted with the little A with a bar on top. You see that little bar? So when we're talking about the complement, A with a little bar on top is the set consisting of all the elements in the universal set not in A. So there's numbers in A. Well, I want the complement of that, which is the numbers not in A. Okay? So for example, if A are even numbers, then the complement of that is odd numbers, and vice versa. Okay? Oh, you got my warranty on my car is up, I think. So again, I'll say that again. Complement is the opposite of what's in A. Okay? So that's kind of true in real life, the word complement, right? If you get married or you're dating this gal or guy, right? And they say you complement each other well, right? You guys go together well, right? Yin, yang, right? You guys know the yin yang? Yeah? Right? My wife and I, they say we complement each other well, right? My wife's a good cook and I like to eat type thing, right? She likes to clean and I like to make messes, stuff like that. No, I don't do that. We complement each other well because we're a good team. We take turns cleaning up after our kids. Oh, man. Anyway, here we go. So we got a universal set. We got 1 through 9 is our universal set. A is, again, the odds, and B is 2, 3, 4, 5, and 7. Well, here they want the complement of A. So here's A again, 1, 3, 5, 7, and 9. And now I want to do the complement of that. So basically, I'm going to go up to the universal set, and I'm going to write everything in the universal set except 1, 3, 5, 7, and 9. So I don't want 1, I want 2. I don't want 3, I want 4. I don't want 5, I want 6. I don't want 7, I want 8. And not 9. So there is the complement. Again, A is the odds. The complement of odds would be the evens. So far, so good. So now, example 7, it says, I want the complement of the intersection of A and B. Well, the first thing I got to do is I got to do the intersection of A and B. So I take a look. A, again, is 1, 3, 5, 7, and 9. And I want the intersection with B, which is 2, 3, 4, 5, and 7. Once I have that, then I'm going to do the complement. So the complement's like the last thing I got to do. Okay, it's kind of like there's parentheses around the intersection of A and B. Okay, so I take a look, intersection, what do they have in common? What's the intersection of A and B? Shout them out. What do you guys see?
3 and 5.
3 and 5. So 3, 5. Anything else?
7.
And 7. All right. So I've got 3, 5, and 7 is the intersection. Well, now I want to do the complement of that. So I go back up to my universal set and I write every single number except 3, 5, and 7. Okay, makes sense? So I got 1, 2, not 3, 4, not 5, 6, not 7, 8, and 9, and I stop there. So I got 1, 2, not 3, 4, not 5, not. Then I have 6, not 7, 8, and 9. Perfect. Final answer is that guy right there. 1, 2, 4, 6, 8, and 9. That's the complement of the intersection of A and B. All right, so the last one, oh my gosh, this is as nasty as you would see it. Okay, this reads, I want the complement of the union of A and B's complement. Well, the first thing I'd want to do is I want to know what B's complement is. So off to the side, I'm going to figure out B's complement. Okay, so I take a look at my universal set. I write everything in the universal set except 2, 3, 4, 5, and 7. So I need what? 1, not 2, not 3, not 4, not 5, 6, not 7, 8, and 9. So that's B's complement. So I got A is 1, 3, 5, 7, and 9. And I'm going to do the union of B's complement, which is 1, 6, 8, and 9 we just came up with. Once I do that, then I can do the big old complement on top. So again, union, what's yours is mine. We put it together. It's a marriage. So we take these two sets and we write them together without repeating. I repeat. You do not repeat. So 1, only write one time. We got 3. We got 5. This guy's got a 6. This one has a 7. And then 8 and 9. Do not repeat that. Now do the complement. So what's the complement of 1, 3, 5, 6, 7, 8, and 9? What are we missing from the universal set? Final answer. 2 and 4. So again, you go to the complement, find the complement, go to universal set, and I don't want 1, I want 2, not 3, 4, not 5, not 6, not 7, not 8, not 9. Final answer is 2 and 4. Okay, so you work on the inside and work your way out. So if you have a complement on the very top over the whole thing, you got to do that last. Final answer, y'all. Any questions with complement and universal sets? All right, so now we got to talk about subsets. All right, so if each element, so I'm looking at this middle box, it says if each element of a set A is also an element of set B, we say that A is a subset or proper subset of B. Okay, so here's the idea. Notice A is inside of B, right? A is smaller than B. The notation that they use for that to show that it's a subset is kind of like an inequality sign, like less than. You see how A is the smaller little circle inside of B. Okay, so A is essentially less than or equal to B. Okay, the proper subset is this one right here. This is the proper one. Just basically says that if A is a subset of B, it can't be equal or the same size as B. All right, that's a proper subset. So let's explain the subset thing. Okay, there's a little formula here that we have for counting subsets. It says if A is a set with n elements, A has 2 to the n subsets. Okay, so example 9, it says write down all the subsets of x, y, and z. Well, how many elements do you have there? There's 3 elements, x, y, and z. So there is 3 elements. So that means I have 2 to the third, or 8 subsets. Now a subset is anything that is less than or equal to. Okay, so they have 3 elements. So I want to come up with all the 1 elements, the 2 elements, and the 3 element subsets. All right, so for example, 1 element subsets. You have just x, right? I'm going to use my fancy brackets here. You have just y, and then you have just z. And guys, that's my z there. So there's 3 subsets that just have 1 element, x, y, and z. Okay? Well, so far, out of 2 cubed or 8 subsets, we've come up with 3 of them. All right, so we have 5 more that we can come up with. So then I go to the next set, 2 element subsets. Okay? Give me one of them. X, Y. Okay? Now, we have to understand that x, y is the same thing as yx. So once you have xy, do not write another subset as yx. That's the same thing. You just have written it out of order. Okay, so xy and yx is the same. So once we've done xy, we cannot do yx. Make sense? So then give me another one. We got yz. Okay, there's one more. We have xz. So we have 1, 2, 3, 4, 5, 6. All right. So out of the 8, we got 6 done. So we go to the next one. 3 element subsets. You already know what that is. That's x, y, and z. So we have 6 plus 1. We have 7 subsets. We're missing one. We did 1. We did 2. We did 3. The last one is, there's no 4. There's no 5. There's no 6. We're missing the Anybody got this one online? What subset are we missing? Wade, any ideas? Hayden, Lauren? Or Lauren's taking a test. Jess, Dylan? We did 1, we did 2, we did 3. Cassidy, what do we got for the last one? Take a guess.
Is it 10?
Good guess. The empty set, the null set, the 0 elements. Everybody forgets that one or doesn't think of that one. Okay, so that gives us our 8 subsets. Okay, so I got 3, 3, 1, and 1. That gives me a total of 8 subsets. Do not repeat them. X, Y, and YX, same thing. Duncan.
There's always a 0 element?
There's always a 0 element, unless they say non-empty. If they say non-empty, then we don't include that one. Okay? This would be our empty set. If they said they don't want you to count that, you would remove that from the sets, subsets. Okay? Now, to answer another question, proper subset. Proper subset up here says that A has to be less than B and cannot be equal to B. So if they say proper subsets, you must remove the biggest one. You must remove, in this case, the 3 element one. So if there's a proper subset you're looking for, that's 2n minus 1. Because you're subtracting the biggest one. All right. Last but not least, before we get out of here, we got a few more minutes left. Example 10, last question of the day. And again, you guys have a worksheet for homework. It says in a survey of 100 college students, 35 were registered in Calculus 2 and 52 were registered in scuba diving. And 18 were registered in both courses. Make a Venn diagram. First off, who in the world would take calculus and scuba diving in college? Who would do that? That's crazy, right? What kind of survey is this? Who would take calculus and scuba diving? Your math teacher, Mr. Gotch.
What college did you go to?
I went to College of Lake County for my gen ed stuff. And that was one of the options. I needed one of those elective classes, right? Well, I could have took another math class, or I could have took scuba diving. What do you think I chose? Scuba diving. It was awesome. If you guys have the opportunity to fill up an elective class, oh my gosh. I went scuba diving at the bottom of Lake Michigan and saw a shipwreck. True story. True story. I learned how to scuba dive, got college credit for it. Oh, man. Beautiful thing. All right, so I'm making a Venn diagram here, okay? I have 100 total students, right? That's going to be my universal set, is 100 students, okay? So you can make a little box on the outside here for how many total there were. There was Calc students, there was scuba diving students, and it says 18 were registered in both courses. Well, that's the middle part, right? That's the overlap. That's 18 right here. Okay? Well, it says here in the survey, 35 were registered in calculus. Okay? So over here, this big circle for calculus was 35 students. Well, how many just took calculus? How do we find that? You know, 35 are in that big circle and 18 are in the overlap part. How do I find that just took calc? Really easy. Yeah, Max says subtract 18 from that. Perfect. I'm going to take 35 and minus 18, and that's what? That's 17. Okay, makes sense. And then there was 52 students that were registered in scuba diving. That's the big circle, right? We'll subtract 52 and 18, 18 from 52, and we get what? 34. There's 34 students that only took scuba diving. Well, now it says how many students were registered in Calc 2 or scuba diving? That means find all of these together, right? So if I want the numbers, and I'm going to do C union S for Calc and scuba diving, right? Then I'm going to go ahead and add these guys up. I'm going to take 17 plus 18 and 34. So that's 35 plus, what is that, 69 students? So visually for me, a Venn diagram is very helpful. You could use this formula up here. Finding the union, you would have to add up all of these numbers in Calc, all of these numbers in scuba diving, but you just added the 18 twice. So then you would have to subtract it. Or do what I do, is just make a Venn diagram and just add those numbers up. Now it says how many were registered in neither course. Okay, that is, again, the complement of the numbers in calculus, union, scuba diving.
Why are you putting it?
What's that? Numbers. N is for numbers, just using the notation that they have there. Question is, why am I using an N? It just represents the numbers in A, the numbers in B. So if I want to find the complement, I'm going to take the numbers in the universal set and subtract the numbers in calculus and scuba diving. There was what, 100 total students? There was 69 that took calculus, scuba diving, or both. So I subtract the two, and that gives me a total of what, 31 students? So 31 students that were surveyed are not taking calculus, scuba diving, or both calculus and scuba diving. They're taking neither. That's the complement. That's the idea. Okay? All right, ladies and gentlemen, chapter 13.1 is done.